an eco machine will be place specific. You have to design for who you are and what your constraints are. What you're seeing here is what it looks like because of our climate and our goals, our educational goals, the fact that we're a seasonal facility. If you go and see an eco machine that exists somewhere else, it won't look exactly the same, but you'll recognize some of the same principles and some of the elements that you might see. John Todd has this experiment that he did in the early, in the 70s in Cape Cod, and he had this. He was actually somebody that changed this after time, got the regulations changed. But at the time, there was just this open pool where industry was putting in all kinds of terrible chemicals, and it was just sitting there, and people were getting sick, and it was just not that far off of the water table, and there's just lots of things that were wrong about this, and John could see that something had to be done, knew that he didn't exactly know what to do, and at the same time thought, well, I've spent enough time. He told these stories of that when he would go and sit by a waterfall and just watch the moss and watch so much that was going on in nature, and studied ecology and did a degree in agriculture and all kinds of different things, but he's an amazing person. So he said, well, there's something in nature that will know how to do this, even though it's too complicated for me to even know where to begin. So he decided to set up an experiment where he would bring in, he was looking for what he was calling the parent ecosystems for help. So he was looking for healthy water because he had a water body that was really sick. And so he went out to find microbiology across, he wanted to find it in the region so that it would be region, specific, but he was going to any, the rivers and the ponds and wetlands and marshes and the ocean or anywhere that he could, what could he bring in and have water that would have different life in it. So he, in some cases he had, trucks full of water that were coming in from these different places, and he put it across this, what he called a constructed river. So it was like, a large, you can see his pictures, it was like a large clear tank that he wanted the light to be able to get into for the life in the system. And then he had all these drums set up that were connected. So on the one end, he started to flow the toxic water through. And as it started to come through, John Todd said it took a couple weeks, and he just sort of watched and observed this entire system, and everything started to self-organize and replicate and do all these different things. And so you had every one of these tanks became a completely different environment, a different ecosystem. So the first one was very toxic, where that water was coming in and only certain organisms and just whatever the life cycle was that they could do, there were certain ones that could select in that first tank and could thrive in there. But they changed the water by the time they had done their life cycle. And so the water in the next tank was slightly different. And so there were different species of all that diversity that would go there. And then there was, another tank with something else. And by the end, he had these racks on top, and he had the plants and the roots of the plants in the system. He had these fish in there. He had, all different kinds of things going on. And so in that original experiment, he actually had a lot of success and was able to take almost, the vast majority of those pollutants were dealt with by the time he measured the water quality at the end. And yet, he was way ahead of his time. Nobody believed that this was even possible, and they thought that, I think they even fined him. I believe he may have said that. And so he decided to take it all back into his lab, and he spent years and years studying all the different plants and the different aspects of the system, and was playing around with the anaerobic parts of it. And he actually says that you want all that diversity. So you need the anaerobic sections as well as the aerobic sections, as well as the light and the dark. And I don't even know the half of the technology, but it's really fascinating the way he's saying, even for us, you don't even have to know every single species you've got in there. All you need to do is make sure you keep the diversity up as much as you can. Whenever you have a chance, bring more plants in there, have more, we'll go out to the lake that's behind the trees here, and you can grab a bucket with the scum on the bottom of the lake. And he was saying that, there's such an intelligence in the natural world that even if you go to the same spot 4 times a year in the different seasons, there's different organisms that are thriving at the different times, and you'll bring those in. So yeah, the idea is just that, the more diversity you have in your system, the more something's going to know what to do with something that's wrong. For us here at Omega, this property used to be an old summer camp. Okay. So if you look behind us, you've got a property on a hill, and interspersed there behind all those trees. So this is about 260 something acres, and there are over 100 buildings. So it is a lot of cabins, and then we have many like different classrooms that we've built over the years, and they're beautiful. And now over, you know, however many years, we've grown into this huge organization with over 20,000 people that come for the programs that we run here over the course of the summer. So for us, when you're here, you're gonna, if you flush the toilet, or it's the gray and the black water. So we're bringing the, you know, the toilets, the sinks, the showers, all of the water that gets used on the campus here at Omega goes through a series of solid settlement tanks, and then it comes down behind us, so straight back there through the parking lot. When you walk out, you'll see there's some, it's marked where there's some yellow poles where we've got the 2 tanks that are buried in the parking lot. So those are the equalization tanks. So we have that water flowing in so that we're able to catch the peak flows. So you have, you know, where the mornings and the evenings where everybody is showering at the same time. So you have a huge load of water that's coming down here. And we'd need a much bigger system if we were just processing that as it came in. So they created that to be able to equalize the flow over the course of the day. And then as we head over here, so you can see the outline of these 2 tanks here. So there's tanks buried here that are anoxic tanks. So this is anaerobic digestion that's happening. So you have nitrogen compounds coming in and being converted and digested and changed to different nitrogen compounds that then are more palatable to the plants. And you're also, you know, having some of the nitrogen then go back to the air as well. So there's a splitter box here that then splits, so all of the water that comes through is coming through here, and then it's actually split in half, so part of it flows each way. And then half of the water, so there's actually 2 different constructed wetland cells out here. So you have half of the water comes out across the front of the building and flows under this gravel into the first cell, and half of it's going to go down to the other end and do the same thing. So right in this area, this is about 4.5 feet deep, and it's basically a large swimming pool with a rubber liner. So the water is not connected to, at this point it's not going into the ground. You have it all being treated here, and then there's it's all filled with gravel. So there's no soil in the system here. You have the plants going directly into there, and the relationships that the plants have both with the microbiology, the roots systems, and as well as the gravel, provides surface space for all the different organisms and the diversity of what's in here. So that's anchoring here, and then once the water, and so out here is all the native plants. So you have the cattails and bulrush. We've put swamp aster and different wetland flowers in different areas of this, and then that is gravity fed down into the second 2 cells. So once it reaches a certain level, it's been in here long enough, then it'll go down to the next 2 cells, and there's a collection at the bottom that's all solar powered, and that is then pumped up into the lagoon. So when we go inside, you'll see the middle of the process. So come on in here. You can also, we'll be able to see a little bit more outside from here. So come on in and just take a look here. So this is 8 feet of water, and tell me what you see. This is 8 feet deep. Yep, so it's pretty dark.
Yeah. I think this is gray water.
So this is the combined. So this is gray and black water that goes through our system. So this is, if you picture these 4 cells outside, the raw material has gone through these 4, so that first cleaning has happened out there, and what we're seeing is the middle. So where we were originally standing, if we were to have lifted up that cover and really stuck our heads in there, that is the raw form, potent stuff. So it would have been pretty strong smelling and a little bit more murky here. So if you look at where that leaf is in the water, the clarity of the water has already come a long way at this point. And even though it's dark because, you know, we don't have lights in there, it's pretty deep, but yeah, you can already see, and if you take a walk around here afterwards, you might be able to actually see that this gets cleaner as it goes that way. So what else do you see in here?
This foam. The suds.
There's foam, yep. So we have, this is an aerated system. So this is an aerated lagoon. So you don't want it to be anaerobic in here. So we have, it's like a fish tank. You've got the, the pumps that are just creating the bubblers basically
What are
in there.
these garden algae like?
I don't know the specific names of the organisms in here, but basically,
The organisms?
yeah, so everything grows in here. So there's thousands of different things that when you, so that leaf, if something stays in the water for a little while, it will automatically start to have all kinds of things growing on it. And they look different sometimes. Oftentimes you have these sort of stringy things growing, but there's all kinds of other things. And we've got these metal racks that you can't see. Sometimes when the sun shines in here, you can actually see the racks that are in there. And that is to create the habitat. So the same way we have it outside, you've got all the different pieces of gravel and the roots of the plants to create the habitat for the organisms to anchor. We're wanting that same thing to happen in here. So we have the racks in here, and then you can see all of these amazing root systems that are all going directly in there and creating that habitat for things to grow on, for them to anchor, for them to have the relationship there. And so one of the things that John Todd's team had said that you want to have a huge diversity, not just in the species, all the kingdoms of life are important to the system. So you would want to have root systems that, some of them have runners, some of them have those aerial roots that you'll see on the other side, some of them have really deep roots, some of them have these sort of bulb roots that keep growing. So you really want to have as much diversity both in the plants as well as all the organisms that are in here. There's snails, if you can see some of the snails over there, and actually along the plants, some days you can actually see a whole bunch of things up on the sides. If you walk around, you'll probably see more. I actually hadn't seen fish in here. We put fish down in the end originally. I hadn't seen them in forever, and it's literally every time I have the kids in here, I'll be like, we don't do fish anymore, and they'll go find them. So I guess we still have fish. They don't come up to the surface all that much.
These plants are water-based, or they are on soil?
So there's no soil.
These are all water.
This is all, so yeah, if you see, these are racks here, so that you just have the metal racks, and that's coconut fiber. And then those the roots just go directly through there. Sometimes, so our maintenance guys will work with the gardener and help cut out holes in the racks when they need to, and then they'll stick the plants directly through there.
It's almost like a hydroponic because there's so much in this water.
Yep. And really, it's they've tried different things. You've got sometimes there are certain plants that haven't done as well. So because if they don't have the root ball, our gardener has experimented with doing a potted plant with the soil, but then just letting the roots go all the way through that down through into the system. But yeah, I mean, we've got the banana plants that have done really well. There's ginger plants. There's this monstera plant was just a little house plant that was in somebody's office. And now it's, we see this entire life cycle. It's taken over the entire place. And there's the roots, the aerial roots over there. We have cut those back so many times, and it's, they're growing in Miracle-Gro here. So it's, it's pretty amazing to get to watch. And I've seen this plant in a cloud forest in Mexico. And it's just really neat to get to see it doing all of this here. I mean, most people have seen this plant as a house plant, but the cone fruits and the flowers that come out every year. I mean, you can see the remnants of the flower. There's this big white petal that comes out. You just can see the old dried up ones there now. But it's fascinating to get to watch what's happening. And it's a living system. So we're constantly having to, our gardener will come in here and, she'll look and see, some of the stuff that happens, like if different insect populations will, some of them will then start to multiply, and we're in this relationship, sort of a give and take of, okay, if something gets too much, then she'll use that rainwater to hose down the leaves. So that's sort of a mechanical way to be washing off eggs and things. And at one point we had a slug overpopulation, so they started to put, you can still see some of the plates in there. They started to put beer in there, and then just it's an old gardener's trick where you have the slugs are attracted to the beer, and then they go in, and that's it. So.
This water is all flowing?
Yep. So this water flows that way. If you take a walk around, you'll see it, going that way. So once it goes through all the cells in the lagoon, it's gravity fed down. There's a sand filter at the end, so there's a recirculating sand filter that's probably, I think, 6.5 feet deep. And then that is the final particulates and all the water that's, once it comes out of there, then the water is clean. And so we had to think about in the design of this project, what do you do with that? We're thinking about doing, flushing toilets with the water, or using it for irrigation to be able to use it directly. You could even do surface dispersal, but just what it would have, all the regulations and what we would have had to do if we were doing any of that, and the infrastructure that would have to be created. At the time, it was just a lot easier to do subsurface dispersal. So what they designed was a big dispersal field, but the only space we had available was here in the parking lot, because there's really nowhere. The lake is really right behind those trees. And so what we're doing is we're pulling the water from the ground. So we have a really important aquifer that we sit over here that is really good water quality. We're very lucky to have great well water. We pull the water up from the ground. We're using that water on campus. It's gravity fed down here. We're purifying the water through the plants and the microbiology, and then it's trickling back down to recharge the aquifer. So we're part of that whole cycle of the water. So again, the water comes through, you're flushing the toilet, it goes through the solid settlement tanks, the equalization tanks, through the anoxic tanks, then through the constructed wetland cells, through the aerated lagoon, then to the final polishing in the sand filter, and then it's let out to recharge the aquifer. So that's the process of the eco machine. Any questions before we talk about the Living Building Challenge? Yeah.
You said you guys were seasonal.
Yeah.
How does the off season affect the?
Yep, it's a good question.
Microbes.
Yeah. So in the off season, this is a living system. So we go from, and this is actually, we're talking about Monday for us. So we're about to, this is the final weekend. And then we're going to have, what used to be hundreds of people here at a time, all of a sudden, the seasonal staff in another week will be out of here. So there's just about 100 of us now that work in the administrative offices throughout the winter. And so we don't live here. So we still have to feed the system. So we still, even though you're talking about going from our peak flows of maybe 36 to 40,000 gallons down to maybe 5,000 gallons. But so we actually move the water around differently in the winter. So we'll change the automatic the system so that we're feeding maybe one cell at a time, but we're making sure to get to everything, because it's all, even though these plants will now die back for the winter, you've got the root systems in here, and there's, you want to make sure that you keep doing that. The other thing is that these cells don't freeze in the winter. So you have the circulation of the water, the movement, as well as the organisms in there. There's a little bit of heat that's produced in the metabolism that they have. What we did find is that, so these past 2 winters have not actually been that bad. I mean, the winter before last, I literally didn't plow my driveway once. It was very strange. We just didn't have snow. But the 2 winters before that were brutally cold. I mean, it was really, really cold. And so what we found is that when the water is clean at the end, it does freeze. And so we had to put in a whole nother layer of insulation to help protect the pipes and the system, so that we didn't end up having a bigger issue. But for the most part, I mean, and the difference is that in the winter, so all the inside is tropical. Right. So the same way we're circulating it differently, we're actually dosing the inside. We can't just bring all the water through the inside in the same way in the winter, because we'd just be freezing the roots. Even though it's not frozen, it's pretty frigid water. Yeah, it'd be too much of a shock. So, yeah.
I guess I'm just surprised that even with the plants died back, there's enough metabolic activity to keep that going.
Yeah, well, I mean, the amount of organisms and diversity and everything that's in here is pretty huge. And I mean, the other thing is that, that we've tried lots of different things. Oftentimes, I think what we're doing now is we'll cut everything back. So once it's really brown, we'll cut it down and just lay it over the top as another layer for the winter. So, but we're not leaving that in here. We don't want soil building up in this. This is literally, it's just gravel and the plants.
Right, so you pull it off in the...
Yep. Mm-hmm. Yeah.
What happens to the water after it filters to the sand?
So the sand filter is down there, and then there's the solar pumps is taking it. There's a big dispersal field under the parking lot. When we go inside, you can actually see the picture of what the technology looks like. But it's basically these big, like containers that are around the trickle cells where you're just trickling that water back down into the ground. So, and if you think of that sand filter, the ground is a natural sand filter. So there's another layer of purification that's happening as this is trickling back into the ground. So there's a lot of things to there's so much more we need to learn, but it's very, very hopeful that, a lot of the answers are there. There's a lot, there's so much of the living systems in this world have spent so much more time learning how to do everything that when we stop trying to think that we're separate from nature and remember that we're part of nature and we could actually work as part of that rather than creating all these ways to do things that are going completely against the grain, we're going to realize that it actually could be a lot more easy. I can't say this enough around just like always asking the question, where am I? And what does that mean? And what are the, who are the indigenous people that used to live here? And everything else about just what it means to be human in this place. And that's going to tell you a lot about what you should build. So I definitely want to wish you as much luck. And I think that, those of us that are now thinking about these things in the world that we currently live in, it's really up to us to do something different than what's come before us. And so I'm really excited to have you here and to hopefully plant some seeds for other things you can go and look for. And all right, well, thank you very much. Feel free to walk around. Yeah.
Really appreciate it.